Hello? 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 Okay. Yes, I am just used to be busy in online webinar.
This conference will now be recorded.
Hello.
हेलो
हेलो हेलो
उससे तगड़ी तो मनी मार्केट थी, स्टॉक मार्केट से
ना। अब तो सबसे बढ़िया स्टॉक मार्केट है।
अरे हम ना उस समय की बात कर रहे
हेलो।
हैं।
हाँ, उस समय था।
उस समय जैसे वो कह रहा था ना कि
स्टॉक मार्केट जितना ऊपर जाए बस पैसा निकाल लो अपना,
तुरंत
निकाल लो।
उसमें तुम अपनी नजर गड़ाए रखो बैंक पे मार्केट।
अबे बैंक मार्केट पे ना, जैसे किसी कंपनी में वो कर रहे हो,
Hello.
Hello. Good afternoon, everybody.
My screen is very visible.
Yes, sir. You
Hello?
are visible. You are
My
visible,
screen.
sir.
My screen is visible.
Not right now.
1 minute. Screen sharing option is.
Good evening, everyone. Can you all hear me?
we are able to hear your voice.
Great. Good evening, everyone, and welcome to this international webinar on advances in water and transport intensive industry for sustainable development. Today we have our speaker, Dr. Gopal Krishnan and Mr. Paul Comfort from USA, who would be talking about topics on water and public transportation. While we live in a world of changes that are so profound and rapid that we cannot achieve this so-called sustainable development alone, because there are so many challenges and threats, and for which each one of us are responsible, and we all have to work together so that we meet this goal of sustainable development. So this particular webinar is a kind of initiative that
वो सर कहते हैं कि उन्होंने आपको बता दिया कि उसमें ऑलरेडी अप्रूवल लगी हुई है,
university has started so that we spread the awareness of the importance of the global challenges, be it the climate change or pollution or degradation of ecosystems or the water scarcity or the importance of public transportation, because everything and every aspect of development is linked to the environmental and climate change. So, as these changes are or challenges are completely inclusive, the solutions also have to be inclusive. And today's lectures or today's talk, I'm confident that they will give an overview about the kind of threat we have to water security and what can be done so that we overcome these challenges in the long run. So we have our first speaker, Dr. Gopal Krishnan, who is a scientist C at NIH and researcher at IGB Groundwater Resilience Project. Years of research experience in many phases of hydrological evaluation. He has worked for 5 years in National Institute of Hydrology, NIH Roorkee, as a research scientist. Before joining NIH, he worked at IIRS ISRO, Dehradun, for 3 years in National Land Degradation and National Land Use Land Recover projects. As a research scientist BNC at NIH, he has established the field network stations under the IVIN project for collecting air moisture at IIT Kanpur, Kanpur University, Tezpur, Jammu, Manali, Kakinada, Sagar, and managed the network till September 2014, with a total of more than 2,000 samples that have been collected. In PDS HP2 project, he has established 26 stations for collection of groundwater, river water, canal, dams on daily basis and the precipitation samples on event basis and has monitored the installation process. He has received his PhD in social science and water management from Dr. Y.S. Fertilizers, a member of ISRS and AWRA. Dr. Gopal Krishnan has research expertise in applying isotope in air moisture studies for resolving the source of air moisture and submarine and identifying the zones for submarine groundwater research in coastal areas. Welcome, Dr. Gopal Krishnan, towards for this confident that the participants will be widely benefited, and we are looking forward towards a quite engaging and interesting session from you. Thank you very much for joining, and you may start.
Hello. My screen is visible. Hello. Hello.
You are visible, sir. Your screen is not visible.
Not visible. So I don't know why it is. Have you allowed me to share the screen? Can you see the screen? Hello?
Sir, your screen is visible now.
Visible?
Yes, sir.
You can see?
Yes, sir.
Hello?
You can see, sir.
Yes, you can see.
Yes, sir.
Okay. Hello. Hello, everyone. I am Gopal Krishnan, scientist at National Institute of Hydrology, Roorkee. So today I'm going to talk on the topic groundwater crisis, a threat to water security. So my talk will be focused on the introduction or background, and then groundwater development and uses. Then I will be showing some case studies we have done, and then on the demand management initiatives. So first I will start about the total water on Earth. If you see the water on Earth is either in the sea or as a fresh water. So that if you see the fresh water, the components of fresh water are ice. They may be your lakes, rivers, soil moisture, atmosphere, biosphere, or groundwater. Then we go for, if you see the hydrological cycle, then for hydrological cycle, the sun is the main driver, which helps in evaporating, and the water will evaporate and it goes to and it becomes cloud on condensation. It comes down on the earth back as precipitation. From precipitation, it will either go as a runoff or it go down in the groundwater, or if we go run down, or it can be joined to the rivers, and again rivers go to the oceans, and this is how hydrological cycle is going on. And if we see the distribution of the earth water, then you can see in sea the 97% is in the sea and 3% is only the fresh water. And in that fresh water, 3% of fresh water, groundwater is 30%, and surface water is 0.3%, and ice caps and glacier it is trapped 68.7%. And from the, if you see surface water 0.3%, 2% is the river, swamps is 11%, and lakes has the dominant 87% of that water. And now if you see the volumes of these water, then we can see here the if you see the cubic kilometer in saline lakes is 85,400 cubic kilometer, river had 2,120 cubic kilometer, swamp water 11,470 cubic kilometer, atmosphere 1,200 and 900 square kilometer. So if you're in the biological and saline groundwater, you can see here it is around, you can see it is a major contributor because it is in the ocean, which has the largest part, and it is 9,400 ppm, and fresh groundwater is about 7,600 ppm, and we can see here about the 10 million of this water is there. So this was the distribution, and if you see the India's water resources in BCM, it is around 4,000 billion cubic meter, and annual water availability is 1,990. Out of this, utilizable water is 1,137 BCM, and in surface water, out of this 1,137, surface water is 690, and groundwater is 447 BCM. So if you see the water stress indicators, according to the Falkenberg, the water stress, when it is about that 1,700, then it is called water stress, and if it is between 1,000 and 1,700, then it is called water deficit or shortage of the water, and if less than 1,000, then it comes under the water scarcity. Then if you see the per capita water availability, you can see in the population, and the water availability has been shown here. The population around 300 million in 1950, and it has gone up to about 1,600 million, and the water availability has gone down, you can see here, to the you can see here less than the 400 cubic meter per person per year. So per capita availability, the world has the more than 4,000. Russia has the maximum. USA, you can say 10,000 cubic meter, and China has also more, and Israel the least, and India is in the list. It is more than 2,000 cubic meter per person per year. If you see the water scenario where we stand, we are in the 133 in the list of 180 countries in terms of water availability, and 120th in the list of 122 countries in terms of the water quality. So what are the water quality issues? These will be either geogenic or anthropogenic. The geogenic regions are also, you can see the arsenic, and then salinity may be the geogenic or anthropogenic, fluoride, this may be also the anthropogenic or geogenic, then iron, nitrate. So this is the groundwater quality scenario. If you see all over India how this is the distributed. EC mainly responsible for the salinity of the water, and salinity is also very much prevalent in pockets in all over the India. And if you see the arsenic distribution, we can see here it is in this Indo-Gangetic belt. You can see these are the red line for the arsenic. So then again, if we elaborate, is the how we stand in the per capita water availability in India in 1951. For the what was the population and what was the water availability? It was very high. It was about 5,000 cubic meter, and which has reduced to about 2,000 cubic meter. Which will be it is not 2,000 cubic meter. It further reduced to 2050. So then we can see here this graph how it is going down against the, and we will be reaching the water stress. Then if this is why the groundwater has the increase. First of the groundwater is the any water which is the subsurface but under saturated condition is called the groundwater. So why the groundwater study have been so important? First is the scarcity of the water resources, then over abstraction or population growth, because demand side has increased. There is lot of demand for the water and it is increasing. And if we search for the previously unexploited aquifer, because we are going deep and deep in search of the groundwater, so we are exploiting more it. And then we see that if the development in the health science become, we have become more aware. So better understanding of the toxicological or nutritional significance of the trace structures, we know, and there have been, we are also aware of the drinking water standards. So this has also led to the development in the health sciences. And then again is that we see urban industry and technological expansion. So new and increased pollution threats to important potable resources has also led to the increased attention on the groundwater side. So if you see the groundwater, if you see this global how regional trends in surface water and groundwater use, in 1900 the global population was less than 1.7 billion, and groundwater withdrawal was about 500 cubic kilometer per annum. But currently it is exceeding 7 billion, and the groundwater usage is more than 3000 cubic kilometer per annum. And because population we are showing, because it is showing the demand side, that the withdrawal is to meet out this demand. Then agriculture is the dominant water user. It is varying from 70 to 90% in different part of the world. So these are the different part of the world. We are seeing that the upper portion is your surface water, and down ground below portion, which is the dark gray shown for the groundwater. So consistent increase in both surface water and groundwater worldwide. Increase in the groundwater use since the 1990s. And these are the major irrigated basins such as the Mississippi, Indus, and the Ganges. The Indus and Ganges basins, these form the part of the India. So if we come to the groundwater use in irrigation global inventory, if we see, we can see here the percentage of groundwater with the, we can see here the are equipped for irrigation, that is irrigated with groundwater per statistical unit and per irrigated grid set in global map of irrigated uses. So this is, hello, hello. So this is the how the irrigation uses is all over the world, and we can see in India it is almost 100%, 80 to 100% in India. And you can see the, and if you see the US map and India map, you can see the how the irrigation demands have increasing. These blue dots are for the USA and these red dots for the India. So some salient points in groundwater responses are: groundwater is the largest storage of fresh water, and being a hidden resource, because we cannot see it. We can see the surface water but not the groundwater. So in terms of impacts of climate change, it is relatively more complicated than the surface water. So groundwater responds more slowly to the meteorological conditions. So groundwater residence time, it is also called the groundwater age, the ratio of quantity in storage to the average rate of recharge or discharge, can range from days to tens of thousands of years or more, which delays and disperses the effects of climate and challenges efforts to detect responses in the groundwater to climate variability and change. So if we see the characteristics of the global water cycle, we can see here, this is the storage, this is the flux. So flux means the input, and then residence time, which is the age, or what is how much time water is rising from the recharge to the discharge size. If you see the groundwater flux, that is varying, it is 12,600 cubic kilometer per annum, and again the storage of this 1.1 billion cubic kilometer, 1 million cubic kilometer. So if you see the surface water, their flux is more than, it's very high than the groundwater. It is 44,700 cubic kilometer against the you can see it is 1 lakh cubic kilometer. Then soil water also has some flux, some plus. So these are the, and you can see the ages of the atmospheric water, it is very less, and in groundwater the residence time is very high. So water remains in the groundwater for a larger period. So if we see the groundwater extraction has been shown by different researchers in different way, and it has shown the different proportions, because there are some regional effects. In some regions the groundwater is extracted more, and you can see if there is more extraction, it will show this steep type of curve. So then the estimates, this is the cumulative groundwater dispersion. So groundwater extraction and depletion, if we see, we can see here how the groundwater depletion is occurring with the groundwater extraction rate is increasing from 312 cubic kilometer per annum to 734 cubic kilometer per annum, and which is resulting in the depletion of 126 cubic kilometer per annum to 283 cubic kilometer per annum. So if we see the global groundwater depletion and potential for changes in groundwater recharge in areas of groundwater depletion, then we see these are the some mountains which show the potential change in groundwater recharge for 2041-2070 relative to 1961 to 1990. These are the generated scenarios on the basis of the groundwater abstraction. So we can see here, this is the non-renewable resource and this is the renewable resource. So the groundwater extraction, how it is increasing, and then it will becoming the worse. So these are the groundwaters are largely stored in the aquifers. These are the groundwater storage units. These are called the aquifers. These are the major aquifers of the world, where we can see our India. Indo-Gangetic Basin is also there. Indo-Gangetic Basin, it forms from the Pakistan. It is a transboundary aquifer, and in the Indus region, it is the Indus zone. Then Ganges is the main central India and extended up to the eastern side, up to the West Bengal, and then it is the Brahmaputra Basin also. It is coming into the IGB. It is the Bangladesh part also, and some Nepal part also. So this is a very large, big aquifer or major aquifer. So this is the groundwater resources map highlighting the locations of the regional aquifer systems. So if we come to the Indian map, it is the resource is CGW, where you can see the groundwater resources in blocks. There are total 6,881 blocks. Out of this overexploited means the groundwater usage is more than the groundwater availability. So if you see, there are 1,108, more than 60% of this, you can see the red zone here, more than 60% of the assessment units are in the 4 states only. These 4 states are Delhi, Punjab, Haryana and Rajasthan. They are either in the overexploited category or in the critical category. So this is the Northwest India, which comes under the, this is also the dark zone of the, in case of the groundwater. Yeah, I am showing you some facts in the Indian condition. Groundwater is an important source of fresh water because 80% of rural and more than 50% of the urban drinking water supply, then responsible for more than 80% of the net irrigation command added in the last 4 decades, and more than 60% of the irrigation requirements. If we see the extraction at a substantial quantum of groundwater, largest user of groundwater in the world at the rate of 250 cubic kilometers per annum, and largest user is the agriculture, because agriculture sector, more of the water is required for the irrigation, which is followed by domestic and industrial sectors. Then extraction is often without due regard, because we don't have that much legislation here, and we don't go for we don't see if the water is there or no. We go dug deep and deeper. So we go, and that's why we are going beyond the aquifer capacities. Then it is putting the extra stress on groundwater. So groundwater stress is in the form of overexploitation, and sometimes overexploitation also leads to the contamination. The water quality is degraded. This may be the either natural or anthropogenic. Natural means due to the minerals dissolved in the underground, this comes into the water, and anthropogenic means due to the human activities, like there are some emerging pollutants also. Emerging pollutants are like in your cosmetics and your drugs and other fertilizers also. These are all anthropogenic sources. Then if we see the stress on groundwater may be due to the climate change effects. These climate change effects may be in terms of the rainfall. If the rainfall is not regular or it is less, then it is surely going to stress the groundwater. So if I am showing you the case studies, first case study I am showing you about the Indo-Gangetic Basin. So the Indo-Gangetic Basin, as I told you, it is the major aquifer extending from the Indus, Pakistan to the then Gangetic Basin. Gangetic Basin means it covers in the Indian side, and then to the up to the Brahmaputra Basin. So I am showing the hydrogeological typologies which we have developed for the Indo-Gangetic Basin. There are so many aquifers from all over the world, from UK, USA, Nepal, and they are from Bangladesh. So this is the then I am showing the rainfall distribution in this Gangetic Basin. There are the regions. If the arid regions, the rainfall is less than 250 mm. Then we come to this Northwest Indian region, where the rainfall is about 250 to 100 mm of semi-arid regions. Then in the central area of the central Gangetic Basin, where the rainfall is about 500 to 1000 mm in 1 year. So if we go beyond this is the some deltaic region, or there plenty of rainfall is there. So a rainfall distribution is not the same in the whole Gangetic basin. It is differing from one region to the other region. That's why there was a need to develop the typology. Typologies are the characteristics of the small unit, specific characteristics in the small units. Then we see the sedimentology. Sedimentology is the how they are formed. They are either formed from the Pleistocene. Pleistocene is the some recent deposits, because these are deposits coming from the Himalayan side, and these are redistributed in these plains. These deposits are, you can see here, these are Pleistocene, and then the current one are your Holocene. These are your recent or current. These are Holocene, and you can see this is the light color. This is a Pleistocene. These are earlier. So this is a Gangetic basin. So these are your active subsidence and overlying megapoint deposits. This is your Nepal portion. It is also coming down, contributing to this Gangetic basin, and there is a Bengal basin. So if you see the Pakistan, Punjab, Sindh, and the Indian Punjab, so we can see here how the Holocene alluvium are deposited in this area. So if you see the aquifer properties, what are these aquifer properties? Aquifer properties are in the forms of your conductivity or in the storage. So conductivity is the how flow in a per unit of hydraulic gradient in a as per the hydraulic head gradient. So when the water is moving, there is some conductivity. So this conductivity differs with the material, aquifer material. Either it is sand. Sand will be the highly conductivity, more conductivity, as in the case of the clay. So and then there's storage. Storage is the release of water from the per unit of the area. So this is the storability and this conductivity. So these are you can see these are very high conductive, and these have very high storability. Then we come down to here, and then in the delta, because the silt is deposited in this portion, that's why its conductivity and your storage is less. So these are all well developed aquifers. Then we come to the Pradesh region, and this it also differs with the region. So it is higher in the when the sand is portion, and it is also differing in the different regions. So then we come to specific yield. Specific yield is the yield per unit of the area. Hello, hello.
Hello. Sir, your
Yes.
screen is not visible, sir.
Not visible.
Yes, sir.
Okay.
We have lost you for 2-3 minutes.
Oh no. Okay. One. Let me check again. Is it visible? Hello?
Not yet, sir.
I
Yes, sir.
am
Now it
showing.
is visible, sir.
Now it is visible, no? Yes,
Yes.
now it is visible.
Yes,
So
sir. It's
this
visible.
this is the previous one. Previous slide was visible. No, this slide visible. Have you seen this slide? Hello.
No, sir.
No,
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 sir.
No,
No.
no,
This.
no,
This. Hello. This.
no,
This.
no,
This.
no.
Yes, sir. This one.
No.
Yes, sir. Yes,
This
sir.
you seen.
Yes, sir.
This you seen.
Yes, sir.
This was visible.
Okay. Then
Yes, this was
this is the groundwater abstraction and depletion. How it has moved. You can see. Here the groundwater. This is the groundwater depletion, and the groundwater abstraction leading to the groundwater depletion. Then I will go quickly because time is also constrained. So this is the global groundwater depletion. We see the mountains of the groundwater depletion in the region, and you can see in India and USA, these are the more, and this is a scenario generated for the how the groundwater is depleting. So then this is the major aquifers of the world. We can see there, and this is the Indo-Gangetic basin aquifer, and it's extending from the Pakistan portion to the Indian portion, and then it is moving to the Bangladesh portion. So this is the Indian Gangetic basin, and groundwater development in India. You see the northwest aquifers are mostly exploited. These are overexploited aquifers where the groundwater depletion is more than 60%. So this is the depletion is mainly, if you see the overexploited, then the groundwater availability is less than the groundwater usage. If it is more than 100%, then we called it is overexploited. So this, like with this, we can see here all these dark zones. So now I have told you the facts about India. This I have told because it is not to be seen, because I have told you are able to hear me. So you heard this, all this? Hello? Hello? So
Yes, sir.
now I will go. Have you heard all these figures now I have told? This is the groundwater
Yes,
is an
sir.
important source of fresh water. All this I have told you. Then I am going to the case study, Indo-Gangetic Basin. This is the hydrology. These are the, I told you, these are the researchers from all over the world. These are India, England, UK, and USA, and Bangladesh, and Nepal. So these are the hydrogeological typologies of Indo-Gangetic Basin and railway aquifer of South Asia. Typologies is the with the properties of a specific unit. So on the basis of this, typologies are divided. So first I will see the rainfall distribution. The rainfall distribution is irregular and erratic. From the, if see in the arid region, it is about, it is less than 250 mm, and it is more than 2500 mm in this portion. This is the eastern side. This is also the Delta region, and in the central part of the India, this basin, we can see here 500 to the 1000 mm is the rainfall. So if you see the sedimentology, how these aquifers are formed, because the sediments are coming from the Himalayan side and these are being redistributed in this side. So the sediment, these are the recent Pleistocene, these are Pleistocene, and these are your current, these are Holocene. So you can see here the Holocene sediments. So how these are distributed. So the Pakistan portion, and this is the in India the more recent, and these are the recent. So then aquifer properties. Aquifer properties, I told you, this conductivity and storage conductivity is the able to conduct the flow, the water flow. You can see here, this if sand is there, the water conductivity will be more. So this portion has the high conductivity and high storage, while this portion has the very low storage because of the accumulation of the silt. Then this is the permeability map. Here so the permeability is varying from very low to the high. This permeability is the also varying due to the sedimentation material. So this is the specific yield. Specific yield is the yield per unit of the area. This is the aquifer property, and this varies from the 0.03 to the 0.15 in the Indian part, and it is something more than the 0.2 where there is the more yield. So well from the unconfined aquifers, and if the aquifer hold these water, then it is called the specific retention. So this is the how the specific yield is distributed in this bending, and then this is the map showing the groundwater depletion. So if you see the groundwater depletion again in the northwest India, it is very high. So you can see it is more than red portion is more than 0.75 meter per annum. So in Punjab and area, sometimes it reaches the 1 meter per annum, and it is 0.7 to 0.25 per annum in this portion. You can see this is the Indus Basin, and there is less extraction on the other part of the Gangetic Basin. So if you come to the groundwater salinity, salinity is the accumulation of salt in the groundwater. So if you see these categories, less than 500 and 500 to 1000 is you can use, and less than 500 is called a very good quality, and it is not of any use more than 2500. It is not, we can use for drinking purposes or not for the irrigation purposes. So these are the saline, highly saline. So, and this is the arid region where there is a high salinity region, and in the central part of India the salinity is not that high. So if we come to the increased salinity, it reduces the types of crop that can be grown, declining groundwater levels, increases pumping cost, energy requirements, and make shallow wells fail. So mechanism of salinity, if we see from canal irrigation in the Indus Basin, then we can see here that something went wrong. Yes, this is the mechanism of salinity. Saline water at depth is drawn upward, and when it is evaporated, the salts are accumulated on the surface. And when rain falls or some irrigation water is applied, these salts go leached down, and these mixes with the groundwater, making the groundwater saline. This is the mechanism of salinity. And then again, one more contaminant is there, that is the arsenic. If you see this arsenic, you can see arsenic distribution in the Gangetic Basin. Yes, this is the arsenic distribution in Gangetic Basin. Here you can see the Gangetic Basin. Arsenic is more in the central part or towards the eastern part of India. So it is very hazardous, and it causes something cancerous also. So here you can see how the arsenic is distributed. Any problem with it? Some issues. So this is the paper we published in Nature Geoscience, where we have found the groundwater quality and depletion in the Indo-Gangetic Basin mapped from in situ observations. One minute. Are you able to see the screen? Hello?
Yes, sir. Yes, sir.
Are you able to see the screen?
Yes, sir. It's visible.
Visible, na?
Yes.
Yes, sir. We can see the screen.
So this is these are the typologies which I told you. When we construct these typologies and we construct a model. So these are developing aquifer typologies which can respond in a unique way to pressures. First after targeting the management solutions. So these are the groundwater. We're targeting the groundwater depleted area. We can focus on these areas and then we can think of the management plans. So population growth and prosperity, increasing demand for food, but is there enough water and energy to sustain this? More than 80% of the water abstracted in northwest India is used for irrigation, and the availability of cheap water has been a springboard for agriculture. You can, as in the some are providing the subsidies and all this. They are using the water for agriculture. So water in many areas, as I have shown you, becoming contaminated. This contamination may be either of the fluoride or arsenic or uranium, or affected by the salinization. Then increasing irrigation efficiency is not necessarily the answer, because sometimes you cannot solve this problem due to this. The second case study which I am going to show, it is about the Punjab. So Punjab is also one of the most agrarian state of the India. So if you see the study area in Punjab, so Punjab comprising 1.5% area of the country, contributing 40 to 50% of the rice, 60 to 65% of the wheat to the central pole since last 3 decades. And it has 3 perennial rivers. These are the 3 perennial rivers. One is Satluj, this is Beas, and this is Ravi. There is also one seasonal river, that is Ghagar, which is originating from somewhere here and is going to the Haryana side. So water potential of all these 3 rivers is about 14.54 million acre feet, managed through the well-organized canal irrigation systems. So, however, the available surface water resources of the state are fully committed, even though unable to meet further demand of water in irrigation for agriculture, which increases the pressure on groundwater resources. So, and this, if you see the land cover map of the Punjab, it is in the Ravi region, and is provided from the Landsat image. And we can see here the most of the belt is agrarian. 55% of the area it is occupying. Their occupation is agriculture, and they are occupying this land for the agrarian area. And 22% is the fallow, and 17% is under the settlement, and other 3% is under the hill area. So you can see the mostly it is dominated by the agriculture, and the map is in the Rabi season. And then if you see the surface elevation Punjab is an extensive alluvial plain gently sloping from over 650 meters. If you see the Punjab here, so this portion, this is a northeast portion. Northeast is here it is Himachal Pradesh, and then here is J&K. So it's some hilly terrain is here, and on the south and southwest region here is Rajasthan, and here it is Haryana. So it is gently sloping from 650 meters. This is a lower belt of Shivalik, so Shivalik region and then it is going down to the southwest region, and it is becoming a flat. and 180 meters in the southwest region. So the southwestern fringe of this region is desertic. This is near to the Rajasthan belt and undulating, but has gradually been becoming level with the extension of cultivation and irrigation. Then we see the rainfall. The mean rainfall is varying from 800 to 1200 mm in Shivalik Hills, 800 to 400 to 800 mm in Foreland Basin, and less than 400 mm in southwest Punjab. So out of percent is during the monsoon season, that is July to September. And if you see the water availability in Punjab, Punjab state has agriculture-based economy. The total water requirement is 61.675 BCM, and surface water has 17.54 BCM, and replenishable groundwater sources has 3.78 BCM. So more of this may be some rain-fed area also. But you can see how the canal and drainage network is spreading in the Punjab area. So if you see the stage of groundwater development, how much groundwater they are using, stage of groundwater development is the ratio of groundwater availability and groundwater usage and availability. If it is more than 100%, this means the more usage and less availability. And if you can see in almost all the districts of the Punjab, the usage is more than 100%. Only barring the 3-4 districts, Pathankot, Muktsar, Fazilka, and Bathinda. Here, their groundwater is, but it is slightly approaching. It is on the critical side. These two, and other is semi-critical side in other 2 districts. So, and in one portion of the Punjab, it is also almost in Sangrur district, it is touching 250%. So, stage of groundwater development is also, you can see, it is very critical. So, if you see the categorization of blocks in Punjab, how they are going to the overexploited category, how they are, you can see from 1984 to 2017, how they are increasing from the 84 to the this data is taken, all data from the CGWB, and here you can see there is in spatial distribution, these are all red zone, red areas, and where the overexploitation is there, and only few blocks which comes under either near the Shivalik regions or towards the southwestern Punjab, where there is a water logging conditions. So there is the water tables are very high. So if you see the groundwater level difference in 2000 and 2016, how the change has occurred, you can see how this is the contours, and the contours are the widening in the lower side because there is a flat, and this you can see the movement of groundwater from southwestern part to the central part was clearly seen in groundwater level contour maps, and that in central Punjab cone of depression was formed due to the overexploited. This part is the most overexploited part of the Punjab, where there is the more water, and the water which is once the water is drawn from this, there is the cone of depression, and it attracts more water. It draws more water from the other areas. So this water is also moving towards this water, this portion. So if you see the rain is the main recharge source of this groundwater. So if you see the month-wise rainfall, so 80% is during July to September. So you can really see this is the rainfall pattern, and this is the average of from 1901 to 2019. So almost 119 years average, where this is clearly showing these months for the high rainfall. So if you see the rainfall trend, and we have done this study in 2015, where we have found that the increasing rainfall trends in the annual monsoon, pre-monsoon, and post-monsoon seasons, but winter rainfall is found decreasing. Here you can see the small blocks. This is decreasing in 11 districts, and if this goes on decreasing, the variability is likely to increase in Punjab, and rainfall has a rising rate at some districts in southwest Punjab, namely Bathinda and Moga, which currently receive low annual rainfall. So when this rainfall will decrease, it will cause problem, and the groundwater usage will be more. Then how the groundwater recharge we estimated? Then the first was the rainfall infiltration method, where the rise in water level in monsoon season, specific yield, and the gross groundwater draft has taken into the account. So you can do, and the second method for the semi-arid regions, which was given by K. which is y is equal to 148, and the log of x minus 880. So when we have plotted this and recharge, we have found the different recharge, and we found that if rainfall decreases by 20%, the recharge is decreased by the 60%. So this is the mean rainfall and recharge. You can see rainfall is decreasing and the recharge is decreasing. So these small red blocks are the recharge blocks, and the difference is there. So the recharge, recharge will be affected by the rainfall. So inferences which we got from the study, this is the analysis of mean aquifer recharge based on 1901 2000 year recharge. Reduction in winter rainfall will result in exploitation of groundwater. In general, a decline in groundwater recharge and resources would be expected over the semi-arid such as Punjab, and there is a need for alternative groundwater management practices to control impacts, particularly in situation of groundwater dependency. So artificial groundwater recharge may become a useful technology under these conditions. So if we say, because Gajraula is in UP, so I want to show you something about the UP also. This data is taken from the groundwater department of Uttar Pradesh. If you see in the Uttar Pradesh, the groundwater level, how it is going in last decade, from 9 to 2018, the pre-monsoon decline was about 17 centimeter per annum, but it was recharged in rainfall due to the rain in the monsoon season. The post-monsoon decline was about 13 centimeter per annum. So this post-monsoon decline is mainly due to the Kharif season, and in the extraction is more. So if you see the about only Meerut district, if we show, then we can show there are the different blocks of Dorala, Kharkhoda, Hastinapur, Machra, Janki-Pura, and Mawana. So here the pre-monsoon decline is about 29 centimeter per annum, and post-monsoon decline is 20 centimeter per annum. It is more than the average of your state. So in Meerut, the groundwater decline is higher as compared to the state. So groundwater management issues and challenges, if I discuss, then overexploitation. Overexploitation regions are Rajasthan, Haryana, Delhi, and Punjab. Then suboptimal utilization, where the utilization is suboptimal, that is Bihar, West Bengal, Assam, the northeast states, because there is ample water is there. Then high dependence on this groundwater is the western arid regions, because there are rainfall irregularities, less rainfall, less recharge, so high dependence on the rainfall. Then low yields and sustainability, because there are no well-developed aquifers in hard rock regions. Water may be stored in somewhere cavity and down to the their yields is very low, and sustainability is also an issue. And then the water logging and salinity. This issue is either in the canal command areas. In canal command area, what happens? People prefer the canal water. They utilize the canal water, but groundwater has not been used. So groundwater rise, and by evaporation, the salts are accumulated on the surface, and it causes the salinity. Then saline water ingress. In coastal areas, what happens? The sweet water is being extracted, and due to the extraction of the sweet water, there is a capture of the saline water, because the water then it draws the water from the sea through, and the water comes to this saline, and the whole the aquifers become saline in coastal regions. Then groundwater contamination. So groundwater contamination issue and challenges the geogenic and anthropogenic. So geogenic is your natural, and anthropogenic is the due to the human challenges in groundwater management. So if you see the groundwater governance initiative, this is by government organizations. There may be some international audience also, but I am focusing on only the Indian initiatives, Indian government initiatives. So groundwater is a collateral beneficiary of some schemes. So there are many schemes, either they are run by the central government or they are from the state government. These initiatives may be from the NGOs also. So if you see the central government measures, they all know this is the Manrega scheme. In Manrega scheme, what happened? Some recharge structures are being constructed all over India, and it gives the employment to the people also. Then is the Pradhan Mantri Krishi Sinchai Yojana. Everybody knows it is for the more crop, So it is the for the making the all the lands comes under the irrigated supply. So around from the 140 hectare, about 65 hectare, I think, is this already comes under the irrigation schemes. Then is the Deen Dayal Upadhyay Gram Jyoti Yojana. As the name suggests, Jyoti, it is in the electrification. There should be more electrification in the villages. Under this plan, And what will happen due to this? The electrification will be there, and the groundwater can govern the groundwater. Then the Pradhan Mantri Kisan Urja Suraksha Evam Uttan Mahabhiyan. It is for the solar energy, trapping the solar energy. This scheme is for solar, trapping the solar energy. Then more of the National Rural Drinking Water Mission. It is focusing on the providing the drinking water to the village level. Then is the Jal Shakti Abhiyan. Last year, a movement was there. It was Jal Shakti Abhiyan. In there were some blocks were identified which were over-exploited, and in this block, this Abhiyan was carried out by 5 interventions. These interventions were the intensive plantations, or increasing the recharge, or reusing the your wastewater. So there are about there were 5 interventions. Those and rainwater harvesting, and then Jal Shakti Abhiyan. Then Jal Jeevan Mission. Jal Jeevan Mission is also an initiative by the central government, where it is focusing on the every household get the tap water. So this is another Jal Jeevan Mission is there. Then the state, these were the central schemes. Then the state government schemes are also there. These are the Mukhyamantri Jal Swabhavananjan Yojana by the Rajasthan government is also initiated by the Rajasthan. Then Jal Yukt Shivar Abhiyan in Maharashtra, where there is there in drought areas, there is a lot of drought areas where there is a less water. So how to conserve water? This is all in the Maharashtra. And then Sujalam Supalam Jal Abhiyan in Gujarat. They are clearing the water storage structures and then deepening them so that the more rainwater can be consumed. Then Mission Kakatiya, again it is on the cleaning the irrigation channels and all lakes and these water structures. These are in the Kakatiya, Mission Kakatiya. Then Neeru Chetu in the Andhra Pradesh, it is also on the water conservation. Then Jal Dharo, Jal Bharo, it is on the water harvesting by the West Bengal. Jal Dharo means more water you can, and rainwater harvesting. Then ban on the early sowing of paddy in Punjab. This is also water conservation, where they have put the ban in the sowing in somewhat in the May, and then transplanting not before the 50. There some legislation passed. So then Khet Talab is also a very useful scheme, where the there some ponds are built, and these ponds are filled with water. They recharge your groundwater also. That water can be used for irrigation also. This is in the Uttar Pradesh. Then Pani Bachao and Paisa Kamao. This is a unique scheme run by the Punjab government, where there is the you save energy and you get the some subsidies or some discounts on your electrical bills, or the Pani Bachao Paisa Kamao. Then other schemes by the various government departments. There are so many schemes where the government are there, and then some demand management by communities. Then water budgeting and reduction in water demand through appropriate intervention. And is the examples is the Hivre Bazaar. Hivre Bazaar is in the Ahmednagar district of the Maharashtra, where there was drought conditions in 1972, but there is now a lot of water is there because they have there is one activist, Dr. Shri Pawar. He was the only postgraduate of that place, and they revolutionized the things. Water conservation activities were intensified, water harvesting structures were developed, and they have their own systems. Then Ralegaon Siddhi, everybody know about the Adna Hazare. That is the Ralegaon Siddhi. That movement was there in Maharashtra. Then Marvi in Rajasthan and Gujarat is also regarding the water conservation. Then Lapuria is also engaged on the Lakshman Singh in Rajasthan. It is in Dudu district in Rajasthan, near Jaipur, where they are storing the water, recharging the groundwater. Then Beed, Jalna and Satara district of Maharashtra. Then again this on the water conservation. Then mostly these are the personality driven. There is a one foundation of Amir Khan also, that is Pani Bachao, Pani Foundation of the Amir Khan. This is a personality driven because activities also there. Then absence of government stock constricts groundwater management. There are sometimes this happens, so they go for the NGOs, and they are putting up some NGOs like them. Then scaling up also scale, because they have some small examples in their village level. So how to spread this as the larger scale, that is also remains an issue. So this is and we did. And I will acknowledge this project, what we have showed, we have carried out. There's a under BGSDFID project, Punjab State Farmers and Farm Worker Commission, and I will thank to the director and I am chairman of the Punjab State Farming Commission. and CGW because I have shown some data of them. And then I will thank the organizers, Mr. Amit Gupta, who has contacted me and asked me to come to this forum and deliver this talk. And I will thank one and all the participants who are present here and who is listening to me and patiently listening. And even there were some problems of the screen sharing and all this. They were patiently listening to this. So thanks to them. Now I will ask for the questions. Thank you very much.
Thank you. Thank you so much, Dr. Gopal Krishna. That was a very good talk, and it was great to see actually your real-time research work and sharing the case studies that you have worked on and the things which are going on in the country. So that was something like the live projects that have been happening. So thank you so much for sharing that, and also for the time and wisdom that you have shared here. I would like to request the audience, if you have any questions, you may leave in the chat box, or you can ask the speaker directly also. We open the platform for any sort of questions that are related to the talk that you want to clarify from the speaker.
Hello, good evening, sir. I am Ahmed Abdi Nasir from Somalia. I have one question, sir. Since the water
Hello.
is... Hello, can you hear me, sir?
Yes, surely.
I am Ahmed Abdi Nasir from Somalia. So my question to you is, the problem against the water is everywhere in the world, not only in India, not only in Somalia, everywhere across the world, the problem of the water is there. My question to you is, every year rain comes, but soon after the rain finish, we have a problem against the water again. Why we as human beings are not doing anything while the rain is existing? We need to, nowadays, what is going in Hyderabad city, located in India, there are a lot of floods. My question, how we can overcome such this type of problem, sir? That's my question.
Excuse me, your voice was not clear. Can, if somebody has heard from the organizers, can they repeat this question?
Yes, sure. I can do that for you. I can do that for you. In all that you have been following what's happening in Hyderabad all the way in the southern part of India. That's very much true. Even I have this question within myself. I'm from Hyderabad. I'm a resident of Hyderabad. So I will happen to visit Hyderabad during last week. The floods are so bad. The city is completely submerged in water. One of those so-called metropolitan cities of India, which we claim as the IT capital after Bangalore, was underwater totally for more than a week. People were fishing on the streets. That was the scenario. Cars were completely flooded. The houses, people were completely drenched and submerged in water level. Some people near neck level. The so-called metropolitan city ka, if this is the status, and imagine the status if there is a place or a village or a rural part of India wherein we hardly probably have a good sewage system or something, and if there are some floods that come up, what would be the situation of the residents, and why are we not able to save this water? Why can't we come up with some kind of system wherein the storm water is actually collected and saved? Why should we always wait for the monsoons? When will we learn? This was the question from Abdali Adnan, if I got it right.
Okay. Thank you for this question. This is a very good question. I want to answer in this way. Sometimes what happens, we plan for the as a normal. Hello, are you able to listen to me?
Yes, Professor, I can hear you.
Sometimes we plan the thing as per the normal things are going on. Like I will show you the example. Last year we have done one study in Sundarban, and we know the tidal effects there and other effects there, and we planted some instruments there, and we have done some study, and we were trying to put some extra storage and recovery problems start the work there. But what happened this year? The Amphan disaster has come, and it has destroyed all our instruments and sort of set up there, which were installed in the field conditions. So sometimes we are not. This is like a disaster things, and sometimes it is when heavy rainfall or something like this. Surely there should be, because we have reached to that stage, we should come up with some solution of these calamities. I can say calamities when there is heavy rains or flash floods or there is cloud burst. So these some should be there. Some should be some solution. We should come up with some solution in this surely.
So my question is still, sir, what can be the solution? What can be the solution? We need to know what can be the solution.
What kind of solution? Like if you know, just like I've shown you the long-term rainfall graph, and we know that this much of rainfall, this is the normal rainfall of a particular place. Then we plan the drainage and city things as per that that normals only. When it becomes higher or slightly more than that, so that it becomes a calamity, and it is not beyond our planning. But we should come with that plan. There are the cells for this, disaster management cells are there, other cells are there, and we should do something like for this. I will quote an example in 2013. What happened in Uttarakhand also? There was a flash floods, and thousands of people they died due to these flash floods. So sometimes these calamities can happen, and once it has happened in Chennai also, and some 2 years back it was in Kerala also. So surely we should be aware and we should be proactive for this. But in the present conditions, I don't think we are that much prepared as the other countries, maybe China or US, for this.
Thank you so much, sir. Thank you so much. I really appreciate it, and thanks to the organizers.
Thank you.
Yeah. Dr. Gopal Krishnan, I have a question from my side. Certainly, one part of it, I agree that we need to plan for the future, but we always keep saying the same thing, that we need to plan for the future, because most of the catchment areas, the lake areas in India are encroached. They are sold for a premium price by the real estate people. The environment committees or the lobby, they just give permissions for that. And whenever we have these flash floods happening or flooding happening, they happen because we have built our concrete jungles occupying the lake areas or the catchment areas. This is one part is maybe plan for the future, but one part is we are certainly abusing the nature, where we are supposed to give its ratio for the green part or the greenery area and one part for its water bodies. We are not doing it. We are so greedy that we want everything. So whenever we observe this, it happens. Most of these water disasters or flood disasters happen because the human beings or we have completely ignored the water bodies or started getting more and more greedy, trying to make it more into a concrete jungle. Because with being a Hyderabad resident, I know what happened with Hyderabad Road. We used to, it was once upon a time a city of lakes. The Musi River was completely, it has been completely flooded because of the heavy rains. There were so many lakes that have been flooded because they were completely occupied by the apartments, constructions, concrete jungles and all this. And now once it was heavily raining, what will it happen? The city was flooded.
No, I'm certainly agree with you, but actually, madam, we are the researchers, and you are talking from the point of view from the policy makers or planners. We are not the policy makers. We are not the policy makers and planners. So that's we cannot.
I am asking as a researcher.
Yes.
As a researcher, can we come up with something wherein these catchment areas or these lakes can have a different, which have already been encroached? We cannot destroy that or ask the people to come onto the streets. But is there something else that the research can help with? We first lay our roads and then again start digging it for internet, for electricity, for storm water, for drinking water. We first do things and then we plan. So can there be some?
We can provide only the technical part of it, but after that it is not we can go for it, because policy makers and planners
So
all
was
sit
there any,
together, or
was there any
academicians should be involved. So
was there any
yes.
technical suggestion that has happened at the central or a state level wherein there was some kind of a solution that was bought for this so-called water management or stormwater management?
Uh, that is there. Just I will quote the examples of. I will quote the two examples. One is the example of Uttarakhand, which was the bursting of some lake, very high altitude lake. So in that condition, you are true that the most of the areas are encroached by the human beings. We should avoid that encroachment. But at the time of encroaching, they see the past 30 years, nothing happened, that nothing will happen in the next year. But we should not take it granted that will not happen again. That can happen again. And like in Kerala also, there was heavy rainfall, and the capacity of some reservoir was exceeding. So it was heard that some water was released also. So sometime you are true कि we should plan and we should not go for that much greed, but again this is the part of this, not of this, but who the people who are responsible for issuing the NOC, or who is allowing such, who are giving permissions, they should be also involved.
Great, thank you so much, Dr. Krishnan. Thanks a lot. That was a very good session. And anybody has any other questions?
Yes, ma'am. I have a question.
Please go ahead.
Sir, I am from Madhya Pradesh. My name is Anshika Rao, and I wanted to ask if there is any system, natural system, with which we can purify already used water. Like we in my home, we use groundwater to wash our clothes. So, is there any natural way to purify it and reuse it rather than throwing it away?
Yes, in last year when the Jal Shakti Abhiyan was going over, then I was the technical officer of the in Telangana state, the Vanaparty district, where they have prepared some structures underground. So what are they doing? The wastewater which is coming from the kitchen or from the washing clothes and all this, it was getting filtered due to the, they have put some structures there, some pebbles, and then soil was there, and then they were storing that water in another tank. So this was one of the system of naturally cleaning and the water, reused water.
Sir, so are there some plants so that we can plant those plants? And I am talking
So
about biological plants that
no,
purify
actually
such
biological
type of
plants,
hard
there are
water.
several wastewater treatment plants, or there may be some sewage treatment plants, and there are different techniques for cleaning that water. I mean, if you see, call over the biological, there is MBBR technology also, moving bioreactors, where the biologically the water can be fresh, cleaned, like their nitrate or other pollutions are there. So that can be cleaned and
Hello?
Yeah. So does that answer your question, Miss Anshika?
Ma'am, I had another part of this question. Actually, I had studied something about raised beds which purify water, like water reeds. We might whenever we go beside a pond, we see some plants and um, grass that grow in the water. So I have heard they also purify water. So are there such type of aquatic plants that purify water in such way that we can at least wash ourselves, not for drinking, but at least we can get that type of clean water with which we can at least wash ourselves and reuse them?
Dr. Gopal, are you there? Dr. Gopal, are you there?
Yes, I am. Yes, I'm here.
Oh, hi.
Can you hear me?
I think we have lost Dr. Gopal Krishnan, maybe some with internet issues. Whoever has any questions with regard to the first topic of today's webinar on the transport intensive water and transport intensive industry webinar on the topic of groundwater and water security, you may leave your question on the chat box and we will ensure that the question reaches the speaker. Good morning, Dr. Paul. How are you?
Good morning. How are you?
I'm well. How are you?
Excellent. I'm going to try to share my screen. Let me know if it's showing.
Not yet. So,
Okay.
dear participants, we have our second speaker for today, Dr. Paul Comfort, who is from Maryland, United States. And he will be talking today on the future of public transportation, one of the most important aspects of the transportation industry and the environmental challenges that we have all over the world. Dr. Paul is a well-known transit evangelist and industry influencer and executive director of North American Transit Alliance, Washington, D.C. He was also the host of top podcast Transit Unplugged and CEO roundtables and the author of the bestseller book, The Future of Public Transportation. He is a mobility futurist and author, a keynote speaker, as well as a musician and an attorney, with a 30-year career as an executive in public transport and transit and government. He most recently served as the CEO of Maryland Transit Administration in Baltimore and oversaw numerous award-winning innovations there, including the development of Baltimore Link Reboot and rebranding of the bus, light rail, and metro subway system, and the Purple Line and the rail project in Washington, D.C. suburbs. He was honored to be the recipient of AASHTO's President Award and currently served as the Vice President of Business Development for the Trapeze Group and the host of iTunes Top Business Podcast. Transit Unplugged named as one of the top 5 business podcasts by CMA for 2018 and first place winner for 2019. He is an expert in leadership and management, organizational improvement, transit, light rail, speed rail, hyperloop, transit technology, transit securities, autonomous vehicles, role of TNCs, improving transit ridership, and state of good repair. I think I can talk, or I will be able to talk about you for another 10 or 15 minutes. That's a huge, wide variety of caps that you wear, right from being a musician, attorney, an author, a technical advisor, whatnot. Maybe you should sing something for us also.
There you go. Well, thank you for that introduction.
Anyways, I'm a transportation engineer by myself. I also did my PhD in transportation engineering, and I visited Baltimore a couple of times and Washington, D.C. a number of times. Certainly the metro project over there is something very impressive, and I'm sure the participants today will be very delighted to hear from you, a person with so much of experience, and I should really appreciate for accepting us and our invitation and spending your time with us today. I won't take much longer, so I'll give you all the podium, and we're really waiting to hear from you.
Well, good afternoon, and thank you for the opportunity to appear before you. I'm excited to share with you today what I see as the future of public transportation. As you mentioned, I have a long career in public transportation and government, and most recently wrote this book that you see on the screen called The Future of Public Transportation. It's a 425-page book. It's available on Amazon. And it went to #1 this year on Amazon as the #1 book on public transportation in the world. And then just recently, I've written a children's book, and it's about the history of public transportation, and it tries to get children interested in public transportation. And my illustrator was a fellow named Sudeep KP. He might even be on the call. He's from India, and did a great job. And we are going to have, the book is available right now on Kindle, and will next week be available in Hindi. so that you can have it in the language there in India. And it's also in Spanish and Portuguese and will soon be in Chinese. Today, I want to talk a little bit about where we're going in public transportation around the world. As you mentioned, I have a podcast called Transit Unplugged, and I've been doing this for 2.5 years. I had 16 years in radio part-time while I was managing public transit systems and holding elected office here in America. And podcasting, in my mind, is kind of like the new radio. Well, this podcast is #1 in the world for public transportation. And in it, I basically interview CEOs and executives of public transportation systems. Would love to get some folks from India on. I've been around the world, and I've been doing it in person, where I interview them in person up until COVID. And so I've visited probably 70 transit systems around the world over the last 2 years, maybe more than anybody else. And I've talked to executives every week from Europe, from Australia, from America, from Asia, from South America, and finding out what's happening in the public transportation arena, especially coming out of COVID-19. It has really been a hindrance to ridership on public transportation. Here's the 7 steps that I talk about. So there's a picture of me back when I was CEO of the MTA. I was Chief Executive Officer of the MTA in Baltimore and Washington. We ran public bus service. We ran a light rail system. I ran a subway system there, as well as commuter bus and commuter train into Washington, D.C., the MARC train service into Union Station. And we had paratransit service for people with disabilities, individualized vans that would go to people's houses and pick them up, take them to appointments. And we were the 11th largest transit system in America. And while I was there, we expanded the system dramatically. And here was an announcement of expanding some commuter bus service. It was part of what I call the reboot of our bus system. Around the world in 2017, 18, and 19, and now in 2020, people are rebooting their bus networks. What does that mean? Well, that means changing the route structure to take people where they want to go today. In a lot of the major cities around the world, the bus routes were laid out 50 years ago, and they've never been comprehensively reevaluated and adjusted. Individual routes have changed, but the nature of where people live and work around cities in the world has changed dramatically, but the bus routes never have. And so that's been part of the reason why in many places around the world, ridership was declining in the early 20-teens, 2010 through 2017. The systems began to reboot themselves and analyze where do people want to go today for jobs. They're reconnecting their systems to the rail system. They're adding higher frequency routes so that you don't need a bus schedule. The buses on the heaviest used routes come every 10 to 15 minutes. They're reducing friction, anything that would slow the bus down, expanding where they offer service, adding in new technology, and making sure they have better communication tools for their riders. These are 7 steps to really improve your public transportation system, whether it's in India, in Bangalore, or whether it's in Washington, D.C., where I live. Well, as I mentioned, we had some increases. The transit systems were seeing some increases in ridership across the world in 2018 and 19. But when COVID-19 hit, obviously the governments across the world issued pandemic guidelines, which required people to not work in their office buildings and to work from home. And so there was a great reduction in ridership on public transportation, 50 to 95% reduction, 95% on some of what they call the commuter train services and bus services. These are routes which come from outside of cities and take people in on long rides, maybe an hour and a half to get into the city. Since people weren't working in the big buildings in downtown, those routes suffered the most. Yes. And then we saw routes reduced. Rear door boarding was put in place because they didn't want people to interact with the driver, so they didn't have them come in the front door of the bus. They had them come in the back door of the bus. As a result of that, people couldn't pay their fares because the fare box was in the front of the bus. And so a lot of systems waived their fares. And then, of course, cleaning was ramped up. And here in America and across the world, from England to Canada to other countries, we saw that the federal government, the national government, got more involved in funding public transportation as they saw it as transporting the essential workers. Even when the pandemic rules were in place, which were severe lockdowns, still most transit systems had about half their riders that were normally riding ride. And that was because these were people who were working at the food markets, at medical facilities, at places which were essential that had to remain open. And so I think the federal government, the national government saw that this is key. Public transportation is not a nicety, it's a necessity. And so they wanted to get more involved in funding it. Here's what public transportation agencies did around the world to mitigate the impact of COVID-19. And these are things that are still being done today and even expanding. I've talked to, I don't know, maybe 40 transit executives over the last few months and picked their brains about what we're doing right now. And of course, I work for a company called Trapeze Group. Trapeze Group is the world's largest transportation technology company. I'm the vice president of the company, and we provide over 100 software and hardware products to all the major transit systems in the world, most of them, from London, to New York, to LA, to Dubai, to big cities in Australia, etc. And so I've talked to some of our clients as well. A big thing that they're doing is what's called health kiosks. So you can see this in the picture at the bottom. This is in Toronto, Canada. My good friend Phil Verster is CEO of Metrolinx in Canada. He was in Australia, then went to the United Kingdom, and now is in Canada, going through the diaspora of the Commonwealth. I guess he'll come to India next. He put in these place kiosks, which will allow people to, get their hands washed, to get their temperature taken, to have their cell phones cleaned. Just interesting things, free services for the riders. They also put in place dividers between the seats. People didn't want to sit right next to somebody on long bus rides or train rides and potentially get exposure. And so they put in, as you can see up top, plexiglass. This is a big thing that's happening. Other people are doing reduced seating capacity. Many systems across the world are now saying, if this bus normally holds 50 passengers, now we're only going to let 25 sit on there. That, of course, was working while people weren't riding much, right? So if you had 50% of your normal ridership, you can do this seating at reduced capacity. I'm looking at the UITP statistics for ridership each week across the world. UITP is the International Public Transportation Union. And ridership is now up in 70% on the bus. Still a little less on the subways. For instance, London Tube is still under 40%. The subway in New York is still under 50%. But the bus services are picking up. And so seating at reduced capacity probably won't work that much longer. But while it is in place, transit systems are providing real-time information for their passengers. So they can go on their cell phone and push a button and see, is that bus full? Are they already at capacity? That'll help them make a decision about whether to leave their home or office to go down to the bus stop. And then people are trying lots of different cleaning techniques on the vehicles. This is a pandemic unlike anything we've known in the modern era, absent SARS in Japan. And so they're trying ultraviolet light on vehicles in many cities like New York, which flashes and supposedly helps kill the germs. Just recently, this week, the New York MTA, which is America's largest transit system, carries about 30% of all the passengers across the country, actually, when it's fully working. They are trying a mist, an antibacterial, antiviral mist in the vehicles at night, and other systems across the world doing similarly. Microtransit is picked up. Microtransit is a type of transit that is more personalized. Companies like Via have done this around the world in major cities. And give you an example of this. Here in Washington, D.C., as you mentioned, you'd been here to Washington. Washington has a very big subway system called the Metro, Washington Metropolitan Area Transit Authority. I used to work for them for 5 years. I ran their paratransit system. I was director of operations. And the CEO of the system is a guy named Paul Wiedefeld. Paul's a good friend of mine. When I was head of the MTA in Baltimore, he was head of our airport, the Baltimore-Washington International Airport. So we became good pals. And now he heads up their transit system, and he had to cut the routes to match the demand of the service. Demand was down a lot. So they cut some evening routes after 9 o'clock, bus service stopped. And that impacted some passengers who were medical personnel, nurses and technicians at hospitals in certain parts of the city. They would normally ride the bus to get to work at night for their night shift. Well, now they couldn't do that anymore. So the city of Washington, D.C. contracted with Via, this microtransit company that provides vans, and the nurses and doctors and technicians that would normally ride public transportation now had another option. So they went on their phone, they push a button when they're ready to ride. it would triangulate their location based on the GPS signal of their phone, tell them where to go out on the sidewalk near their home, and a van would come by and pick them up along with other people who were going to the hospital at that time, who worked there, and take them, into the hospital. So it gave them a very personalized option. And this is something that's being used around the world in cities for people to justify a fixed route bus, but there are people who absolutely need it. And so microtransit is a lower cost potential option that is not regular route service, but it's more demand responsive. It's really going to be, I think, one of the long-term things that happen as a result of this COVID-19 crisis is that transit agencies and governments will analyze what's the best mix of services. Maybe we shouldn't have fixed route service everywhere. Maybe instead we should hire some of these smaller companies to go out and pick people up individually based on their demand. And the fare might be larger. There may be a higher fare than normally. Right? If the bus is $1 to ride the bus, it might be $3 because this is more personalized service, almost like a taxi. And then, of course, mass on board. A lot of agencies are still requiring that. I wrote an article for Metro Magazine a couple months ago on what I called the 5 long-term implications on transit of COVID-19. Number 1 is the death of the fare box. What do I mean by that? Well, most transit systems across the world charge for riding a public bus or the subway, and there's a fare box at the front of the bus. And a lot of that is involving cash. And a lot of systems want to move away from cash and move toward electronic faring, whether it's a card or a credit card like a Visa or MasterCard, or whether it's e-faring like on a phone or a wearable, which is like a bracelet that has a chip in it. And so a lot of major cities now are doing away with the fare box or are on the way to doing away with it. For instance, London, Transport for London, I was able to visit there about 4 years ago and visit with their chief technology officer, Shashi Verma. Shashi is a brilliant man, and he helped lead their transit system to do away with cash. So no one can use cash on the London transit system anymore. They have to use other means of fare payment. They have a multi-use card called the Oyster card. And at that time, Shashi had led the introduction in the Western world of tap and go cards, which are the use of credit cards, where you could just take your credit card and it's called contactless faring. You don't actually have to touch it. It can come within a few millimeters of it. But you touch it and you don't have to swipe it. It has the signal that comes out of the card, and you can pay for your fare that way. And within 6 months of introducing that, 40% of the riders on TfL were using that option. So very high and quick adoption of that. And now that's being used across the world. Folks are also going to go to all-door boarding, as I mentioned, because they can put fare validators, which are little screens which you tap your card in. If you're not going to have a fare box, you can open up both doors in the bus because you won't need people to come in the front to interact with the fare box. They can just tap and go, which will allow the bus to board much quicker. In major cities across the world, one of the things that slows down a bus is the line of people, the queue of people getting on the bus, paying their fare. And a lot of times there's multiple types of transactions that will take place at the fare box. And so that will go away if they go to all-door boarding. Commuter services will be slower to recover. You might recall that here in America, we had a terrorist attack on 9/11/2001, and they were using airplanes to attack our buildings, the Pentagon and the Twin Towers in New York City. And so Americans were afraid to ride airplanes for a long time after that. And I looked at the statistics at our national database, and it took 18 months for people to return to ride airplanes like they used to. And I see that being analogous to the commuter services, that they're going to be slow to recover like that because they're longer rides. People are a little more concerned about that. And people are realizing that they don't have to work from the office anymore, that they can work from home. A lot of the major cities now are seeing their rental of their offices going down. People are going in every other day to work, not every day. Some people who can use Zoom or Teams or other things like GoToMeeting like we're using today, they realize, architects, et cetera, I don't have to go in but one day a week for in-person meetings. So anyway, I think commuter services, which largely serve people going to work, will be slow to recover. And then I think there'll be increased federal funding and the cleaning protocols will have to continue. As I mentioned earlier, one of the major ways, I talked to 50 transit leaders around the world during 2018 and 19, and the number one ways that they were using what I call the silver bullets to increase their ridership were rebooting their bus networks, focusing on jobs and population shifts, increasing the frequency on key routes such as headway management, and reducing the friction, anything that slows the bus down, such as multiple functions being paid at the fare box, and then adding in bus-only lanes in cities where buses can travel on them, and that helps them get through the congestion in the central business districts or transit signal priority. In my book, The Future of Public Transportation, it actually was not written by me, but it was written by 40 of the world's leading transportation experts. As I was editing the book and reading the contributions from the various authors, I realized that I kept thinking to myself, oh, there's one more thing I want to talk about. And so these are some of the things that came out of the book. On the safety side, people are now asking for public hazard reporting by cell phone. So this is a new option where if you see something, a hazard on the bus service, you could snap a picture of it on the app that your transit system uses, and it will be reported to the transit authorities. People are moving toward improved asset management. They need to really track their assets better now in the era of COVID to know exactly where the buses are at all time. There's software available to do that, and hardware. The Internet of Things, IoT, with telematics, integrated buildings and equipment. This is a brand new era in the world of public transportation. Some of the interesting facets of how it's being used in our era, in our arena, is buses now. Some buses now have all kinds of integrated internet on them, and so they can determine through machine learning when a vehicle is going to break down before it breaks down. I can tell you, having run a major transit system, that a vehicle breakdown is one of the worst things that happens in a day, on a day-to-day basis in a transit system. When a bus breaks down with passengers on it, dozens of people are sidelined. They're missing their appointments to go to where they have to go. A bus has to pull over. Another bus has to be dispatched there. They have to find exactly where it is and find a safe place to unload the passengers and put them back on. Then you have to send a major tow truck to tow it back. Every time a breakdown happens, it costs thousands of dollars. And so having this information available where it says, hey, if the engine is going to get a certain temperature based on the information that the computer has, this bus will actually have a breakdown. And so it tells the driver and dispatch ahead of time. My company sells software that does this actually, as do other companies. It will tell the driver, stop, pull over, and or return to the yard, or let the passengers out, and dispatch can get involved. This is the kind of new safety improvements that are happening in transit. And the safety management systems are the data-driven decisions. So I'm sure you understand that in most transit systems, they have an operating budget and a capital budget. The operating budget pays for salaries, electricity of the buildings, those kind of things. The capital budget pays for bricks and mortar improvement and for brand new rolling stock, which are the buses and the rail cars. A lot of times when capital budgets are made each year, it's based on anecdotes and stories and information from the managers of those service. Hey, I would like to have this new equipment, but it's not based on data. And so now transit systems across America and the world are better analyzing their assets and grading them each year and saying, this is a B, C, or D, or E grade, A being the best. And it's the ones that are in the lowest columns that receive funding now for improvement, not just the stories that are told by the managers. The One More Thing chapter at the end of my book, these are 3 takeaways I wanted to pass on to you today. As I mentioned, there's all kinds of new internet-based and high-tech-based improvements happening for bus drivers and for mechanics. And so transit systems need to make sure that they're developing workforce development, teaching these new skills and functions to their employees. As things like autonomous vehicles really take hold in this decade of the 2020s, these are vehicles without a driver. I've got to ride them from Switzerland to Las Vegas, the first autonomous vehicle in the world that operated in regular public transit service was operated in the Rhine Falls, Europe's largest waterfall area. The transit service was operated in the Rhine Falls, Europe's largest waterfall area. I got to visit it and ride it a few years ago. But so autonomous vehicles are becoming a big thing now. And so this will change the skill set of drivers. Public-private partnerships, design, build, operate, maintain, and finance, DBOMF. This is a way that big capital projects are being built now, a brand new way where governments aren't necessarily coming in and paying for everything and constructing it with themselves. So for instance, when I was head of MTA in Baltimore, I was overseeing the development of the largest public-private partnership in America. It was a $5 billion project called the Purple Line outside of Washington, D.C., a 16-mile light rail line which connected into the metro subway system. And we did a design, build, operate, maintain, and finance. So these companies would come in and design it, build it, operate it, design, build, operate, maintain, and finance. So these companies would come in and design it, build it, operate it, maintain it for 30 years, and then help finance it. They'd have money, they'd have skin in the game, as we call it. So they would be invested in it themselves, which obviously led to them being greatly involved and wanting to make sure that it worked. And then the last thing is that there's a new concept happening, which is shared air travel. VTOLs, I don't know if you've heard of them before, but they're vertical takeoff and landing vehicles. Last year, just before the COVID-19 crisis hit America, I was able to moderate a panel in Las Vegas called Go Nevada. That's the state that Las Vegas is located in. And it was about the future of public transportation. And I got to moderate this panel with the head of Uber Air and also the drone, both. I mean, the next day, Uber unveiled their vertical takeoff and landing vehicle. They call it Uber Air. It's basically like a helicopter, which takes off, and then where it pulls you up, and then the wings pull back, and it pushes you forward very quickly. And you could ride multiple people in this, not just one person. It's like a shared helicopter, basically. And they plan to have more unveiling of it next year with cities in Australia and Dubai and here in America. And then unmanned and manned drones are happening in China right now. These are things that are happening when it comes to public transportation and moving people. The last thing I want to share with you is the top 10 ways to future-proof a transit system. I've covered some of these already, but I will talk about them just a little bit more today here in this presentation. So what do I mean by future-proof? Well, as you know, the COVID-19 pandemic may not be the only pandemic we have, or there may be a resurgence of it. People are figuring out that, hey, I need to make sure that this doesn't happen to my transit system again. And so one of the ways they're doing that is to move towards zero-emission buses. These are buses which, as the name says, has zero emissions. So these are electric, CNG, hydrogen fuels, and it emphasizes public transit's clean nature. We've kind of taken a black eye in public transportation over the last 6 months because many folks have felt like it's unclean to ride on a transit system, that there's germs. Now, they've done a lot of studies just recently, just yesterday, UITP came out with a study that showed that's not really true. But we can return more into the public's mind that we are clean. We talk about the nature of our vehicles being clean for the environment. New tech tools for back office scenario planning and rerouting service and adjusting rosters and shifts quickly and seamlessly when needed. These are the software tools which will allow folks to analyze very quickly which routes should we adjust. Adding in high frequency routes, as I've mentioned already. This is another key way to improve your transit system. Putting in new software and hardware that allows for better tracking of the assets, buses and rail cars, facility cleaning, and showed where each of the vehicles were. But that is old that's what we did up until 1980s, you know? And this is like, 2020 now, and there's software and technology tools that are available that will allow people to kind of know where the vehicle is real time. And that's what people need to do. And so that's one of the ways in which we can improve our services. Other ways we can the top 10 ways to future-proof our services, contactless fare, and we've already talked about this, but this is moving away from traditional fare boxes, emphasizing e-faring, wearables, contactless card. It speeds boarding and allows for all door boarding and is low touch, meaning there's not a lot of cash involved. Moving to micro-transit, as I've already mentioned, and detail. And this is a big one, adding real-time passenger information. This is the latest, greatest trend right now across the world. Because so many transit systems are still limiting the number of people on the vehicle, from Australia to the United Kingdom to here in America to Canada, everyone is limiting the number because they're trying to stop the spread of COVID, and they feel like if we have everybody jammed in there, that could be a problem, even though they have masks on. And so letting people know ahead of time, the bus coming up to me is full. Now, people could get off the bus at your stop, and that information then would be irrelevant, right? But they're also adding now, some companies are adding extra information on the app, which says the historical trend. This bus has been full 78% of the time at this bus stop, the one before, the one after, over the last week or month. And that allows people to get better information. The other thing that real-time information can do is you can share with your passengers when this vehicle was cleaned. if the bus was cleaning, if the buses are being cleaned every hour. You can have that information up on screens in your bus stops, etc. Online mobile trip booking. What does this mean? Well, a lot of places across the world have individualized service for people with disabilities, and they book these trips by calling in and talking to a reservationist. Here in America, we have a law called the Americans with Disabilities Act, which makes it a civil right for people with disabilities who don't have access or can't get on a regular fixed route bus service to have individualized service brought to the curb in front of their house. Many cities now actually even go up to their door, where the driver will walk up to the door and help them out. So I've run, major call centers before. In Washington, D.C., I ran a call center where I had 70 reservationists all sitting right next to each other. You can't do that during a pandemic. You can't have people sitting right next to each other. And so moving away from that model to allowing more people to book their trips online, to book them on their phone, gives them more control of their trip, but also keeps it so that you don't have to have all these folks sitting right next to each other. Autonomous vehicles, I've already talked about. They provide a niche service as part of a comprehensive program in your transit system, and then adding mobility as a service. It's a brand new concept which started in Helsinki, Finland a few years ago. They had an app called the WIM app, and basically now it's spreading across the world. It's aggregating all the public mobility services in a city on one smartphone app, which passengers can plan for and pay for their services and even subscribe to them. So what does this look like? I was able to visit Dallas, Texas a couple years ago when they first were getting this going, and they have a great model, Dallas, Texas does. It's called DART is their system, Dallas Area Regional Transit. So basically they have a smartphone app, and on that app they have the bus, the light rail, all their transit system services, but they also have on there Uber and Lyft, and they have on there rental cars, they have which you can rent, by the hour. They have on there other services in the city that are transit related, even if they're privately operated. And so a person can kind of aggregate what their trip would look like and make it the fastest way or the cheapest way to get where they want to go. So they push a button and they say, I want to get there the fastest. What's the best way to get from my house to downtown Dallas right now? And it could tell them, okay, well, you want to then have a taxi cab come pick you up at your house and take you to the train station. Then you get off there and you get on the light rail vehicle, which leaves at such and such a time. Then you ride that downtown. And then when you get off, there's a rental bike right there, which you can rent and drive and ride it the last 3 blocks to your office, or you could walk. And then the passenger will say, yes, I want that option. And it's all paid for through an account that they have online. And they don't have to pay for each option. They just show their phone. They have a squiggly UPC symbol, and they'll scan that. And then that's how they get to their service. So this is a great new option, which is happening across the world. And even now more than ever is a big part of how people are solving future-proofing their transit systems. As I mentioned, I've got this brand new book. I encourage you to take a look at it online. It's a picture book. It talks all about the history of public transportation from the Tom Thumb Railroad, which was the first steam engine railroad here in America. Rail service started right here in Baltimore, where I was the CEO, called the Baltimore and Ohio Railroad System, B&O Rail, in America, and all the way to Hyperloop and beyond. And so this shows children and cartoon pictures, wonderful illustrations, all about public transportation, and gives them an appreciation for it. It's available, as I mentioned, in Hindi, I think next week. It's in English now. And then these are ways which you can contact me. I'd be happy to continue to interact with my friends in India. I have a website called thefutureofpublictransportation.com with information about my books and blog posts from other leading transit leaders across the world. My podcast, if you get a chance to listen, it's every week we have a new guest from around the world. It's free. You can get it on iTunes or any place where you normally get your podcasts, or go right to Transit Unplugged and subscribe, and you'll get a link to the show each week. I have a blog series on my company's website, and you can follow me on LinkedIn. I put up something brand new every day about public transportation on LinkedIn or on Twitter, Instagram, or you can email me at paul.comfort@trapezegroup.com. I'm happy to do these kind of drop-in speeches. My company has me on board basically as their industry thought leader, and they're free of charge. And for transit systems across the world, I've been dropping in, doing staff meetings with them and doing presentations similar to the one you see here. So thank you. That is my presentation, and I'm happy to take any questions over the next few minutes.
Thank you. Thank you so much, Dr. Paul.
Unmuted. That was very
That was a very crispy presentation and transit areas. Dear participants, do you have any speaker?
Yeah, I can hear you. There are a couple. Sound like people talking.
Anybody has any questions for the speaker? So this book is available on Amazon.
Yes, it's available in India for Kindle. Ebook download.
Okay.
Yes, Professor, I have one question for you. My question is that, sir, as you know, nowadays every family is buying cars in the world. Why the society are instead of using government transportations? Why everyone is buying? This is polluting. The air is polluted everywhere. How can we stop that kind of problem? Every family is buying 3 to 4. That if every family is buying 3 to 4 cars, and everyone needs to drive by himself. So, and the problem of the pollutants, earth is polluted. How we can solve that?
Yes, that's a really good question. I think part of the reason why, especially now that COVID is we've been in COVID now for 6 or 7 months, a lot of folks were afraid and are afraid that they're going to catch COVID on the bus. And so this is what we're seeing across the world in major cities, is the car transportation is picking back up quickly, and people are buying cars faster than they had before because they're afraid to ride public transportation. But as I mentioned, there's a number of studies, I've shared them on my LinkedIn page, that don't show a real link between COVID-19 transmission on public transit vehicles. People aren't talking on public transit vehicles, so they don't have the spray coming out very much. Most systems require people to wear a mask. And so actually the rate of transmission on public transit vehicles is very low as compared to just having, dinners in your own home with family members. And so I think the fear that people have is a reason why people are going back to cars. And you're right, it is leading to an increase in smog and pollution. You may have heard that during the height of the pandemic, when people were not driving their cars as much, that people from Los Angeles to Shanghai could finally see the skyline, and they could see the beautiful sky because all the smog from the vehicles wasn't in the air. And so you're right, the way to keep us being able to see the skylines is to be able to keep people out of their polluting cars.
Thank you so much, sir. This is Ahmed Abdul Nasir from Somalia. Big salute to you, sir.
You're welcome. Anyone else have any questions? Happy to answer any questions about public transportation or anything about what was in the presentation. I hope to visit India one day. One of my best friends is from India and has wanted me to come back there. So hopefully I can come visit you all sometime in the next couple of years once we get these travel restrictions lifted.
Great.
Well, thank you very much.
So should I assume there are no more questions from the participants? Okay. Thank you so much again. Thank you, Dr. Paul, for all your time. And we really appreciate your time and sharing your knowledge with us. I'll definitely try going through the Kindle format of the book that you have written on the future of public transportation. And I'm sure the participants must have been really excited listening to you, and I'm sure they must be taking something, they must be having a good amount of takeaway from this lecture, because following the comments on YouTube, Facebook, where we have been live for the session, and even over here, I see a lot of good feedback coming from a lot of participants who are really happy with the information that has been shared. So thank you so much, and I would like to thank the team IRCC for organizing this webinar series, the management of Venkateswara Group of Institutions, especially the Chancellor, Dr. Sudhir Giri, who has been always very positive and enthusiastic about international researchers and international faculty or international experts sharing their knowledge to the students or the faculties, because they bring in the global atmosphere and the global happenings and research that have been going on everywhere. And webinar or the virtual meetings have something made it very easy. One of those positive things of COVID probably is that before, if we have to meet somebody or discuss with somebody, people used to just follow the conventional method of meeting or organizing stuff. But with this COVID, there is so much of gap that has been filled with the virtual meetings. We are able to connect with different parts of the world, cutting down all the cost, all the legal formalities, the visas and stuff, and still able to listen and talk to each other. So thanks to COVID to that, and the participants who have really appreciated the session that has been organized. Thank you very much. And IRCC would want to engage much more activities and webinars in future as well. Thank you everybody, the IT team who has been supporting us, the management, the team IRCC, the speakers especially who have taken all the time, Dr. Gopal Krishnan and Dr. Paul Comfort. Thank you very much, sir. And we look forward for maybe some other session whenever you're free.
Thank you. Bye-bye, everyone. Have a great day.
You too. Have a good day. Thank you so much.